Hi folks, this is a solution for number 7 on page 170. Okay, so they give us this cubic function here where 3 of the coefficients are unknown, and the information they give us is that the equation, the function increases to the point -318, then decreases to the point 1, -14, and then continues onward, increasing. Okay, so let's take a look at how we can use this information to determine these variables. So here we have 3 unknowns, so we need at least 3 pieces of information. We already have 2 because we know points on the curve. Okay, and you have to think here that if the function is increasing to this point and decreasing, that means that the derivative must be going from positive to negative. Okay. Now the only way a function can change sign is through a 0 or a discontinuous point. But given that this is a cubic function, we know the derivative is going to be quadratic, and so will be continuous everywhere. So the only option is for f prime at -3 to be equal to 0, and for f prime at 1 to be equal to 0. Okay, where it changes sign again, where the derivative would change sign from this time negative, decreasing function, to positive, where the function is going to be increasing. Okay, so in fact it looks like we have 4 pieces of information, so we even have more than we need. Now, as I've done before, when I'm trying to solve this system, I'm actually going to start with the derivative, because in taking the derivative I'm going to eliminate that that c unknown. Okay, so let's start by finding the derivative. So f prime of x is just going to be 3x squared plus a times the derivative of 2x. The derivative of x squared, which is 2x, so 2ax, plus the derivative of bx is just b, and of course, as we said, the derivative of c is just going to be 0 since it's a constant. Okay, so let's start with this first piece of information. So f prime at -3 is going to be 0, so we've got 0 equals 3 times -3 squared plus 2a times -3 plus b. So 0 equals, this is 9 times 3 is 27. This is going to end up being minus 6a plus b. Okay, so I might as well get my a to be positive here, so I'll bring the a and b terms to the other side, so we get 6a minus b is equal to 27. Okay, so there's one equation with my 2 remaining unknowns, so let me now create a second equation with those unknowns. Okay, so now I also know that the derivative is going to be equal to 0 when x is equal to 1. Okay, so here we've got, I'm just going to do this in my head, 3 times 1 squared is 3, plus 2 times a times 1 is just 2a, then plus b. Okay, so here we can write 2a plus b, and we'll bring the 3 to negative sides, the other side, so -3. Okay, so I'll bring this over and solve this system of equations now. Okay, so this is the system I'm solving, and I can just do that by adding the 2 equations. So here's 6a plus 2a is 8a. These are eliminated, and so I'm just left with 27 minus 3 is 24. Okay, and so a is equal to 3. Okay, let me use this second equation to solve for b. So b is going to be equal to, bring the 2a to the other side, so -2 times a, which is 3, minus 3, and so b is equal to -6 minus 3 is -9. Okay, so here we have 2 of our unknowns. Okay, so now we actually have a choice of which point to use. Okay, if you did want to check, you could do it for both and see that you would get the same answer for C. Okay, but 1 -14 seems a little easier, so here for Y I will input -14 equals, so it's x squared, so we're working with 1 -14, x cubed. This is what I'm inputting my 1 into for x, and a is 3, b is -9. Okay, so here we've got 1 cubed plus a, which is 3 times 1 squared, plus b, which is -9, times x, which is 1, plus c. So here -14 equals 1 plus 3 minus 9 plus c. So C is equal to negative 14 minus 1 is negative 15, minus 3 is negative 18, plus 9, so negative 18 plus 9 is negative 9. And there's my C value. Okay, so just to recap, okay, here you have 3 unknowns you're looking for, so you need at least 3 pieces of information. 2 were given directly, these 2 points. The other 2 pieces of information that were available, we had to figure out by analyzing the increasing and decreasing behavior of the function. Okay, so since the derivative had to change sign, and we knew that the derivative was a polynomial, this had to occur where the derivative was 0. Okay, that's it for this one.